So in vector algebra, now we are moving to vector multiplication. Okay, so let me classify vector multiplication in two categories. First, multiplication of scalar and vector. So how does this uh, multiplication takes place? So let us suppose we have a scalar k and a vector a. Then their product will be straightforward, k times a. So magnitude of a uh, scaled by a factor k. So it affects its magnitude. Its magnitude is increased or decreased as per the value of k. For an example, we have momentum. So momentum p, which is a vector, is equal to mass, which is a scalar, times velocity. Okay, I forgot to tell you that multiplication of scalar and a vector is a vector. So the final uh, product is a vector. So that's all in this, the product of scalar and a vector. But what if we want to find multiplication of vector and vector? I mean one vector with other vector. Then there are two possibilities. First, if product of two vectors is a vector, then we call it vector product. And if product of two vectors is a scalar, it is also possible, then we call it scalar product. So vector multiplied by vector, if it is giving a scalar, then the product is called scalar product. Or dot product. See, be very careful. For multiplication, if a and b we want to multiply them, so we can just write them close, ab. That's the multiplication of a and b. Or sometime we write them in bracket. Or sometime we write them as a dot b or a multiplied b. Or sometime a and star b. But here symbols have very specific meaning. So if we are multiplying two vectors and the result is also if result is scalar, how will we know, how are we going to know that the product is a scalar quantity? So for that you don't worry for now, uh, but later on you will come to know which quantities are scalar. And if two vectors depends on that quantity, if two vectors need to be multiplied to give that quantity, then we will go for scalar product. So if A and B get multiply to give C, which is a scalar, whereas A and B both are vectors, then in order to denote its scalar product, this is important. Putting an arrow over them is important, and then put a dot in between them, and it should be a visible dot. And I'm not saying that you do this much, no, it should be a dot, but a visible dot. And see, if you write A dot B, it is just the multiplication of their magnitudes. If you write AB, it is nothing. It is also the multiplication of their magnitudes. But if you write, this is meaningless. So be careful. What are you, how are you denoting its product? So A dot B is C. This is the dot product. And it has an expansion. It is expanded as A B cos theta. Why cos theta? Why not any other thing? Yes, I will explain it, but little later on. A B cos theta. What is the difference between this A and this A? So this is its vector value. Vector value dot with vector value of other is equal to magnitude of first one, magnitude of second one, and cos of angle between them. Okay, now if we talk about uh, vector multiplied by vector, and if answer is also a vector, then such type of product is called vector product or cross product. Cross. It means A cross B. See, this is not just an ordinary multiplication, it is the cross product symbol is equal to C with vector sign. Here it was a scalar quantity, so end result was a scalar. Here end result is a vector, so its expansion will be A B as same as that of in scalar product, but there will be sine theta, and not only just sine theta but a unit vector also, so that this entire value becomes a vector quantity. And here this n cap is given by right hand thumb rule. If this is A, this is B, and this is just the plane lying in my hand. Let us suppose they are not in this plane, they are in this plane, horizontal plane. So I'm taking A cross B. So I will hold my palm like this, and A cross B. I will turn my finger A cross B toward that second vector, and then the direction of thumb will show the direction of their cross product. So this is that unit vector n cap. So if in my palm this is vector A, this is vector B, so if I curl my finger from A to B, then direction of thumb will give the direction of their unit vector or their vector product. Ultimately, their product is this. So this is the direction of their vector product. So that is important. It means if I want to find B cross A, then I will not go like this. I have to turn my hand down. Now the direction is downward. Uh, the same is not a foundation here. So here it can be A dot B is equal to B dot A. But here A cross B is equal to minus B cross A because of direction. So remember this thing. Okay, what else? Yeah. So let us suppose, just I'm continuing below this. If vector A is ax I cap plus ay j cap plus az k cap, and B is bx I cap plus by j cap plus bz k cap, then A cross B is equal to uh, I cap, oh sorry, here I have to find A dot B. So A dot B, in order to find A dot B, I have this formula, but what I can do, I can take the magnitude of A, I can take magnitude of B, and if I know the angle between them, I can apply this formula and I can find the answer. But I have an alternate also. I can directly multiply both of them like this: ax I cap plus ay j cap plus az k cap dot bx I cap plus b y j cap plus bz k cap. And see, there will be 9 combination. We can simply multiply it and there will be 9 combination. But here is a catch. What will be the I dot I? I cap dot I cap. So if I follow this expression, A means magnitude of I. Magnitude of A is A. So magnitude of I. What will be the magnitude of I? What is I? I cap is the unit vector along x-axis. So mod of I will be 1 because it is unit vector, its magnitude is 1. Multiply, don't consider it as cross products multiply sign. Now these are just the number, these are just the magnitude. For magnitude you can use any of the symbol, but for vectors you be very specific. Okay, 1 multiplied by 1 multiplied by cos theta. What is the angle in between I with itself? I with itself, 0 degree. Cos 0. Cos 0 is 1. So I dot I is 1. Similarly, same will be j dot j and same will be k dot k. But what about I dot j? Again 1 into 1 into and cos 90. Cos 90 is 0. So means I dot I, j dot j, k dot k will get scalarly multiplied and give value 1, whereas I dot j, I mean which are distinct, they will vanish. So straightforward, we need not to bother about it. We can directly write ax bx plus ay by plus az bz. Straight away we can do this. All right. But the cross product is not that simple, and you can see there's no I cap, j cap, k cap here. Means it is totally scalar value. Now what about cross product? So as we know, it is sorry, not here, here it is a b sine theta and n cap. Don't forget this n cap, that is very essential part of this vector product. So again I am taking same two vectors and I am multiplying them. So but before that, let me check I cross I. What will be I cross I? So according to this, the magnitude of first, which is 1, magnitude of second, which is 1, and magnitude of and sine theta. So it is sine 0. And let us suppose there is some n cap. But sine 0 is 0, so it means I dot I is 0. Same is j dot j, and same is k dot k. Okay, now moving on. What about I dot j? So I, magnitude of I is 1. Oh, sorry, I cross j. Magnitude of I is 1. Magnitude of j is 1. And sine, the angle between I and j, x-axis and y-axis, that is 90 degree. I is 1, j is 1, sine 90, but one thing is missing, that is n cap. And what I told you how to find the direction of cross product. If this is x-axis, this is y-axis, this is I cap, this is j cap. And we are taking multiplication I cross j. I cross j. So thumb is coming out. This is k. This is k. K cap. So I cross j is k cap. J cross I is 1 into sine 90. Again, k, ultimately it is k cap. J cross I. J cross I. It is going inward. Minus k. So it is minus k cap. Final product is minus k cap. Similarly, j cross k, you can check yourself, or you can yeah, you can trust me as well as you can try it out. J cross k is I cap. K cross j, sorry, k cross I is j cap. And if we take it in opposite manner, k cross j is minus I cap, and I cross k is minus j cap. So you can see 3 combination vanish here, and 6 combination remain there. Okay, and that will be difficult to find. So ultimately, if we multiply them, that is difficult to find, because we have to write 6 combination. And what are those 6 combination? See from here, I and I will vanish, j will vanish, k will vanish, ij will give us result, uh, and yeah, so ij will give us some result, but when we'll take ji, that will be in negative sense. So it will be little bit messy, but we have a method by which we can solve it easily, and that is called determinant, what you want to say. uh, for that you have to just follow my instruction. So you can rewind from now onward till I explain the thing again and again till you get the complete idea of it. First, write ijk. If you want to find cross product, then put the coefficients of ijk, which are ax, ay, az. Let us suppose there is no az there, and in fact no bz is there. Then you have to consider it as 0 k cap and 0 k cap. So you can't miss anything while taking cross product. If there is only a is equal to axi cap only and b is this one, this much, then still you have to take axi cap, 0 j cap and 0 k cap. So be very, very careful about it. Okay. bx, by, bz. Step 1. Write, okay, draw bracket. Leave this column, leave this row. And now multiply a with bz. Ay bz minus by az I cap. Then put a negative sign. Why is it so? Reason is bit lengthy. It is meaningless to talk about it in this video. It is totally mathematical, so I'm not giving its explanation here. Okay, now we will leave this row and this column. So it is ax bz minus bx az j cap plus, now leave this row and this column and multiply. See, whenever we are multiplying from up to higher to lower, this higher level to lower level, this second row to third row, we'll taking them as it is. But when we are multiplying this to this, third row to second row, we are changing the sign. See, student, you k cap. You might find that anything happening here, but no, it is not. Actually, whatever be the result here, there would be 6 combination, and there is a possibility that we could just miss some of the signs. So in order to avoid that confusion, mathematicians have devised this. Actually, it has certain different meaning, but here it is for us to arrange these 6 quantities in this manner. And that's all. This is a cross b. If there is a numerical value, we can find the answer, and you can see I, j, k. So it is totally a vector quantity in the end. So this is how we are going to find this dot product and cross product. I am right now not giving some numerical examples of dot product and cross product, but theoretically I can tell you some of the dot products and some cross products. So dot product examples and cross product examples. And see, be very careful while like there a cross b equal to ab sine theta n cap. So that ab is just the magnitude. Be careful about it. and you need to put proper sign, otherwise you will get confused. So dot product examples. First example is work. So work is W equal to F dot S. Force and displacement both are vectors, and work is a scalar quantity. There's another kinetic energy. K or Ke equal to half m v dot v. Finally it will become v square, so nothing to bother about. Third is power. We know power is work upon time, but it is also force dot velocity. There's fourth. This you are going to study in next class, in class 12th. It is called electric flux. Denoted by phi subscript E, which is electric field intensity dot area vector. Oh, that's a surprising thing, how area is a vector. So let me tell you briefly that area is a vector and its direction is normal to the surface. Like if I calculate the area of this board, so its direction will be normal to its surface, and arbitrarily if we choose it length into breadth, so it will come out. So that is why area is a vector. Fifth, magnetic flux. Phi b, b is for magnetic field vector dot a. Okay, now cross product. First is linear velocity equal to angular velocity cross r. V equal to omega cross r. Uh, like if this is rotating in a circular path, this is r, and its angular velocity, as I told you, the direction in which it rotates, this is omega. So omega cross r, so linear velocity is going this way, and that is why it is moving that way. So second one is angular acceleration. Linear acceleration is equal to angular acceleration cross r. Same thing. Third, angular momentum. Denoted by L, which is equal to r cross p. Linear momentum, r cross p. So if it is rotating like this, this is r, and it has momentum downward, so r cross p, it has angular momentum along this direction, and if it is going this way, then momentum that way. And fourth, torque. So torque